Hello, Mr. Brown here, your science teacher. I make videos for students of all ages. Join me today as we study the science of light. Light is an electromagnetic wave propagating through space with alternating electric and magnetic fields perpendicular to one another. What does all that mean? I don't know. It's just really complicated. Let's move on. For a long time, people were wondering, is light a wave? Is it a particle? What is it? Well, after performing the dual slit experiment and the photoelectric effect, it was determined that light is both a wave and a particle at the same time. Mind blown. Well, let's move on. Okay, so light travels fast, 300 million meters per second. How fast is that? Well, in the time it takes me to say, oh, one Mississippi, you could go around the earth 8 times. That's how fast light is. But there's more to light than what we can see. There's a whole world of light that we can't see. We call this the electromagnetic spectrum. Let's take a tour of the electromagnetic spectrum, starting at the longest wavelength and lowest frequency, and that is radio waves. Okay, radio waves are very low energy and they can't hurt you. In fact, right now in your house, you're being blasted by radio waves every day, and it just doesn't hurt. Like the Wi-Fi signal in your house uses radio waves. What would happen if you were to receive radio waves at a frequency of 94,100,000 hertz? Well, you'd say turn it up because you're receiving a broadcast from Solid Rock 94.1 JJO, broadcasting out of Madison, Wisconsin. That is coming in at a frequency of 94,100,000 times per second. Let's move up the spectrum to a shorter wavelength and higher frequency called microwaves. Now, you probably recognize those from cooking food in a microwave oven, but did you know that cell phone towers broadcast using microwaves? Let's get a little bit further down the road in infrared waves. This is also known as heat. Here we can see some infrared heaters keeping those French fries warm. And this guy has downloaded an infrared app on his cell phone. You can see the heat coming off that dog. Did you know that the remote control for your television uses infrared? Let's move down to the only part that we can see with our eyes, visible light. Visible light, when run through a triangular piece of glass called a prism, breaks light into the colors. Roy G. Biv. Who is this Roy G. Biv fella? Well, it's not actually a guy. It's just a way to remember the colors. Roy G. Biv is red, orange, yellow, green, blue, indigo, and violet. These colors can be thought of as different wavelengths of electromagnetic energy, with the long wavelengths of red all the way to the short wavelengths of violet. You know, raindrops actually function as little prisms breaking sunlight into the colors Roy G. Biv. And every rainbow you ever see will always have the colors in this order, always. You know, you can actually go on Amazon and get these things called sun catchers, and they take sunlight and they break it into an amazing blast of rainbows. I have this in my house. It's really super cool. Moving up to ultraviolet light. This is also called UV radiation. This person has suffered ultraviolet radiation burns. We call it sunburn. You know, Ultraviolet light can be used by detectives to find hidden blood stains. Here, you can't see it in visible light, but under ultraviolet, a crime has definitely taken place here. Did you know that bees can see ultraviolet light? Here's the same flower under visible light, but under ultraviolet, it looks much different. Let's go up even further up the scale into the higher frequencies and shorter wavelengths of X-rays. I am looking for my car keys and I just can't find. Oh, there they are. Here's an X-ray of a dog. And would you guys stop playing around in the X-ray machine? This is expensive equipment. Come on. All right, we've made it up to the most powerful, shortest wavelength, highest frequency gamma rays. Gamma rays will slice right through you. It'll slice through just about anything. The only way to stop it is with lead shielding. Now, don't be like this guy and experiment with gamma rays. It will not turn you into a rage monster. It will actually just kill you. But we could actually use the deadly power of gamma rays to fight cancer. Here you can see how it is operating on this brain tumor. This is a dangerous place here as gamma rays are shooting out of this black hole. Today, we've gone through the entire spectrum of light. Thanks for joining me. I'll see you next time. Bye-bye for now.